Today we will talk about co-creating games on mobile. My name is Przemysław Kazimierz Krąpiec. Don't freak out. It's my Wi-Fi password, actually. I'm Polish, so only Polish will understand this name. I don't see any Polish in the audience, but if there are any, just raise your hand. I will feel better. Oh, yeah, there you go. Yeah, two of us. So we can exchange our passwords later for Wi-Fi. Yeah. Anyway, in my company, actually, everyone knows me as Polche. Sorry, I went to the side. So sorry. Everyone knows me as Polche, so they don't know my Wi-Fi password pretty much. The project owner of our co-creating games project is Bowen Wang, my good friend. He couldn't attend today, so on his behalf, I will do it today instead of him. And also, Huli is gonna do the second part of this talk. So yeah, let's get started. First, I will tell you what Yahaha is. If you haven't heard, we are a 3D UGC platform that supports a lot of modular tools and components that make life easier. So creating games and metaverse experience is quite easy on our platform. Also, we stress a lot about no code. So we have a lot of solutions for users. So they don't need to have a lot of knowledge about coding and all that advanced game design stuff. Besides that, we host a lot of services like multiplayer is built in, so it works right out of the box, as well as cloud services. So as soon as you save your project, it's going to be saved on the cloud and you can access it later from wherever you are. Additionally, our company was founded in 2020 by former Unity members, and now it reaches more than 200 workers, from whom I think 80% are in R&D teams. Also, we have launched our alpha version last year in April, and it had reached and attracted more than 100,000 users, and they have created more than 10,000 different contents from games to other experiences in our platform. So if you're quite interested, please try it. We have our apps on mobile, on Android Store, on App Store, and also you can download it from the website, yahaha.com. So yeah, please check that out. So first of all, I will just play a video so you can see what we are. Yeah. Okay. So that's that. Okay, then now I will start actual talk about building games together on mobile. My part is more about the background and the concepts of this project, and my friend will continue with the hardcore technical and engineering part. So have that on your mind. Okay, so another video. So first of all, you need to see how our co-creation works and looks. Yeah. So anyone can yahaha. That's our motto actually. And yeah, why do we focus on co-creating? Well, as you could see at the end and at the beginning, anyone can yahaha. We follow this motto over several years now, and we want to make it easy for everyone because everyone can be a creator. It's pretty much similar to YouTube. Anyone can be a creator, or YouTube doesn't have to be an advanced filmmaker or someone else. You can just upload any video and be a creator. And the same way, Yahaha works. So we are trying to deliver those tools. So wherever, whoever, whenever you want, you can create your own worlds and games and just play them easily. So that's first thing. Then the second thing is we listen to the voice. Yeah. So we have a big community, as I mentioned, and a lot of members of this community are developers. So they are asking for co-creation because obviously a lot of developers want to work together. Especially, we have launched several game jams recently, and there was a lot of comments about that. So yeah, there's a lot of pressure. And then also game lovers, they want to enjoy their games like Minecraft or other sandbox experiences. They want to have that kind of feature in our platform as well. So that's why we have worked on this project, and we are going to deliver. So the concept of co-creation, we think that it splits into several factors. Like it should be more fun, then everyone should be able to do it, and we think that mobile should go first. More fun means that creating games shouldn't just be that hard work that everyone does, developing all that hard stuff. It should be more like a game actually. And then everyone, like I said, anyone can yahaha. Everyone could just invite their friends, family members, or just meet some people online and create those games, those fun experiences together. So that's another thing. And then mobile, as you may know, everyone has a mobile now. Maybe sometimes even two or three mobiles in some cases. So we think that by focusing on mobile first, we can reach the biggest audience there is, and then just follow up with other platforms. Because as you could saw on the first slide, we are a cross-platform. So we support PC, obviously other devices. So yeah, I will just speak about each of these three factors in detail. So to make it more fun, as I said, we believe that 80% of fun means collaboration. So when you're working together, you can exchange ideas, you can talk, you can just relax and chill and experience everything together. So you don't have to be alone there, like the old time devs, where you can be having a social experience while doing it. Also, we think that providing smart assets and game templates is also the key to make co-creation and game development much easier, because nowadays not everyone wants to learn how to do, for example, some kind of low-code scripting or just creating 3D models for their games. You should be able to just use the existing things and the smart assets that the platforms provide. So that's the focus that we are taking. And also, as I said, everything should be easy. And pretty much Yahaha feels like drag and drop. You just drag and drop all the things you need and just configure them as you want and use them to your extent. As much as you want, you can just use everything. So yeah, you don't need to do everything from the scratch. And as I said, teamwork. So teamwork is a very important thing because creators can talk to each other. Like I showed you in the video, people were chatting. People because we support a lot of services, so the multiplayer experience is already there. We have also voice chat as well, so you can just do voice chat while creating your space. Another thing is that, for example, in Minecraft, if you're creating something in Minecraft, and then your friend in the chat says, "Come check this out." You actually have to check the info and find the XYZ position where the character is and go to him and then find him or find a way to get there faster. We provide solutions like, for example, the teleport. So you can just swap in click that button and just teleport yourself to that character that you want to see or just you want to talk to. So that's also something that we are trying to provide right out of the box, so people can have an easier experience and just have fun with it. Yeah, and it should be ready. It should be playable instantly, pretty much. So, for example, I showed you in the video, players were creating a it's called a ladder experience. So it's a game that just the spring falls down and whoever touches it dies. And they were testing it. There were some bugs, so they could just play it right away. And when they experience the bug, they can just stop and jump back to the editor and edit it together, or find some more fun experience or more fun solutions and just update it and play again. So it's a matter of a few seconds, I believe, because we do not need to publish. We do not. We do not to take that long time to publish or to build our content. We just play. We just press play, or we just press save. And then publish also works the same way. It's just 1 second. You just press publish, and the space is already uploaded on our server, and anyone can access it, actually. So just try to imagine how fun would it be to invite your family, for example, and just build something from your imagination with your mom or dad or your friends or other people. Yeah, that just is quite interesting in our opinion, and we are trying to explore even more options in that direction. And also at the beginning in the video, you could see there were some fireworks saying anyone can Yahaha. So we have developed a fun firework system. So you can edit your fireworks and just set some messages, for example, to have more social experience in it. Like, for example, if you would like to, I don't know, make a wedding proposal to your loved ones, then you can just prepare that and make a metaverse proposal to your loved ones. So yeah, the game templates, obviously nowadays, everyone needs a template. It doesn't matter if you're writing a proposal for a science paper or whatever, you just need some kind of set of templates to know how to do it. Everyone Googles stuff and everyone looks things online. And this is why we are providing a lot of templates, so users don't have to go through all that hard work and time-consuming work just to think what they can make in our platform. And the fun thing is that you can use these game templates to your extent, but by that I mean that you can tweak them in any way you need. So, for example, you can change a sandbox game experience to a racing game or to something else. We are providing a lot of them, so you don't have to do all that hard work. Especially, I said that we are focusing on mobile co-creation, right? So try to imagine that you have to develop all those hard things on the mobile device. I don't know if any of you sitting here right now would have the courage to do all that programming and creating everything from a scratch on a mobile. Yeah, it would be just time consuming. I mean, it's not impossible, but it would take a lot of time. So if there is someone who could do it, you can raise your hand. Probably we might hire you right away. Yeah, that's just a joke. Anyway, so yeah. Remixing everything and using all the things that we provide is pretty much the start that you should do while you experience Yahaha, while you use Yahaha. Obviously, you can do everything from the scratch. We do provide empty spaces, so you can just build. If you're a hardcore developer, you can build from zero. But yeah, we stress that you should be using our assets because it's a smarter way. And you can significantly enrich your experience, your game, as well as the community can also benefit from that, because we have a very big asset library and anyone can use that. And also you can upload your own assets to the asset library and share them with other users. So yeah, everyone can help everyone, and it's just scalable. It just grows rapidly. Whenever you upload something, someone else can just make use of that and make your life a better life, pretty much, or an easier life. So yeah, drag and drop use. Like I said, I will have a session actually later, so you would be able to see how good I am at drag and dropping actually in Yahaha. Yeah, we have tons of smart assets from just 3D objects to components that can be reconfigured to whatever you want. So, for example, if you want to make a shooting game, if you want to make a racing game, we already have pre-built components, for example, like a car, which you can download. It works like kind of like GTA cars, so you can sit inside of it, get out of it, drive obviously and stuff, and you can exchange the models, tweak the parameters and stuff. So it's very versatile and very easy to use. Sorry. And also, yeah, if you want to do whatever you want, you can remix even our components. So you can just build very difficult and very fun and creative logic while using and while mixing all these components together. Yeah, and like I said, the second main thing that we are focusing is that it should be for everyone. So, like I said, no coding requirement is the thing to go. The thing that we should focus on because not everyone can be a programmer. So we are trying to deliver no coding experience to the Yahaha user community because we believe that the general creator is what matters, and there's a lot of these normal people that just want to be a creator, but they don't know how to do that. Yeah, and also another things that are quite important is low system requirement because anyone should be able to use it. And so the game, I already mentioned the game templates and different game types that you can create. Why this is also important for everyone is because not everyone wants to make a shooting game. So we should make a lot of game templates and make it available to users so they can make whatever game they want with a lot of templates that we provide. So that's also very important, and also cross-platform. Although we are focusing on mobile, cross-platform should also be available for all the people that just want to use a PC or a tablet, or maybe they want to play games on their TV without a specific device like a PC or console. Then it should be just streamed, right? So we are focusing on that as well. Although co-creation for now on is specifically for mobile, and we are starting from this point. Yeah, so the no coding requirement, like I said, everyone can be a creator, and like the Infinity Stones in Avengers, they gave a lot of abilities to, for example, Thanos. He could just swap his fingers and snap. There's half of the world and the universe is gone. For us, it's snap and you can create a universe pretty much. But we don't limit ourselves to 6 Infinity Stones. We have a lot of them, and they're called components and smart assets. So we have a bunch of them to create different logics like moving, reacting, rotating, and also, for example, AI behaviors. And yeah, for example, we can add tags or we can mark some objects that can be pickable. So the character can just go close to within some range of the object and can pick the item, and you don't have to code a lot. You don't have to do all that time-consuming work. You just drag and drop, and the item works like an item pretty much. So yeah, that's quite interesting. Sorry. Okay, yeah. So, like I said, we are better than the Infinity Stones because we have a lot of them, and mixing them and remixing them with all the assets in our library. And I don't know if you remember, but at the first slide I showed you, we have more than 1 million 3D assets on our asset library, on our asset store, and they're free now. So you can just use whatever you want, really. And some of them are from CG Trader. Some of them are provided by Yahaha directly. And a lot of them are made by the user community. So it's all a bunch of different things that you can create. And if you think about it, you mix a 3D asset with a component, and you can create a lot of different logic, a lot of fun stuff with our platform. And the fun factor here is that we also allow this to be remixed by other players. What I mean is that when you create something, for example, if I make a building in Blender, for example, and upload it to Yahaha, it becomes available to all the users in our community, and they can download my building. But then someone just downloads my building, and adds some VFX to it and some moving objects and maybe some other logic. He can then re-upload this asset, and then other people can use it again. So you see, it's just exponentially growing with this kind of solution. So everyone contributes to our platform, and it grows rapidly. Yeah, and the variety of game types, like I said, everyone likes different games. I, for example, like sandbox experience, and I like games like Minecraft. So I would go with the adventure mode, and there's no time limit. There's no typical game goal to do. You can make your own quests in our platform and just play in this mode. But if you want to make a racing game and a quick fast and paced game that you play on mobile devices, then yeah, you can do that just by clicking and using our game template, or in the editor you can just use for example, on our desktop we have something called an assembler, which is pretty much a questionnaire. So this questionnaire works like this: you get a few questions, you answer them, and the Yahaha editor just builds up all the logic for you. So you don't have to think what you should drag, what you should look for in order to make something complex. You can just go through a bunch of questions and ta-da, it works. Like the Avengers assemble, pretty much, right? Yeah. So yeah, like I said, low system requirement was also a very important thing, and we are optimized for cross-platform. That means that we should run on pretty much everything. Maybe it's very yeah, I cannot say everything pretty much, but smart devices like iPhones, Android, consoles, PC, you can do that. iPhones from 7 above, and Android from 8.1 Snapdragon, then it should work fine on our platform. Also PCs, I mean, everyone has a PC or a tablet, so you can run Yahaha as well. And as you may know, everyone has a phone. So yeah, everyone should be able to use it. And then mobiles first. Yeah, that's the principle that we are focusing on, because we, especially the young generation, uses the phone most of their time, less than the PC actually. In my time, I was using the PC almost all the time, and I still do actually. But the phone is somewhere there. Even if I travel, I have my phone next to me. And on the train, for example, it should be easy to access all these fun things and just create your own games while you're traveling and doing everything. So we stick here to a design principle that is very typical for mobile devices. So for example, drag and drop and touch screen, these are the actions that you will be doing. And then we also provide a lot of rich editing features and rich feature property editing, so that you can create a lot of interesting content. So the design principles are obvious. That means it should be intuitive. So you should be driven by your instinct. By that, I mean that you should just touch your screen with your finger and drag the component to different objects on the screen, and pretty much it should work. Then on the screen, due to the fact that mobile devices are quite small, and my fingers, for example, are quite big, then it means that less is better, pretty much. So we are trying to constantly think about how to make it better for the users so they don't see too many things at one time. So we are trying to squeeze all these features and different components and options so that the user doesn't get scared at the first time when he sees our co-creation mode. And also, yeah, what you see is what you get. That's an obvious principle. Means that as soon as you drag something and drop, then it should be there at the spot where you dropped it. And also, as you may know, a lot of us using devices require some kind of feedback. And this feedback makes us more secure, makes us understand that what I did was finished. So for example, we use haptic feedback to indicate that some action was performed and finished, so the user can feel the phone vibrating when he dropped something or changed some parameters. Yeah, so these are the principles. And then I said rich editing features. By that I mean, if you have ever used any 3D tools like Blender, 3D Max, or Maya, then you know that there is this three-dimensional axis, X, Y, Z, and then you can just drag objects along these axes and just manipulate them. And then most of the editing tools have rotation, grabbing and moving, and then, for example, scaling, copying, and deleting. So pretty much we have all these things built in, and you can use it with the touch of your finger, like in that small video. Oh, sorry, why was this skipping? Sorry. Okay, so yeah, what's going on? Sorry, I don't know why it's skipping like that. Yeah. So the properties as well, you should be able to change them in an easy way. Like you see here, you just type in some values, select the parameters you want to change, and it's changing like that. So it's very simple. And you see, there's not too much on the screen, so you're not being, it's not too crowdy. So you can access everything and you see everything in a very easy way. Obviously, this is the pre-version of this UI, so we might change as we go and just make more fun together. And we also, like I said, listen to the community. So if the community says, maybe this window shouldn't be transparent, and later on we will consider that and we might change it so that everyone or at least most of our community users likes it pretty much. And then yeah, so as you can see, drag and drop. So we do all the crude on game properties: create, move, delete, edit. Yeah, all that stuff works right now. And then stop. Yeah, sorry. And what's next? So actually, we are thinking about three things again. First of all, we should remix more things. By that I mean not only game templates or smart objects, but pretty much everything. So if you have a game on our platform that someone used, or maybe we as the platform provider has provided, and people like it. And let's say, for example, I like that racing game that Yahaha has uploaded to their server. Then they should be able to remix that game. So pretty much they should be able to download the game, add their own features, maybe change something, and make it their own game and upload it to our server. So it's maybe a totally different content from the one that we made. So we want to make that happen. We want to enable DIY to everyone with everything, pretty much. Another thing is make everything more better by adding advanced settings. So we are thinking about adding scripting to the mobile co-creation mode. So this is just an idea that we have. We don't know still yet how it's going to go, but we are thinking about it. And the third thing is AI co-create. By that I mean just speech to creation. Use the AI so that use the AI so that it recognizes what I'm asking for and just builds what I'm asking for. If you're interested actually in this topic, we have another session today about this. We have already an AI solution for text to create being tested on our platform, and it works quite nice. I saw it. If you want to see a video of that feature as well, then you can visit our booth, which is in the southern hall. And yeah, that's that. And then the next part of our Yahaha talk today will be done by He Li, and he will have a deeper dive in the technological aspect of all the challenges we had while developing our studio editor. If you have any questions to me or later to him, please wait till the end and we can answer your questions. Thank you. Come.
Great thanks to Porche, giving us a very impressive introduction to the co-creating. Here I like to give some technical details about how we implement the co-creating of our Yahaha runtime. So here, firstly, when we start to trying to implement the co-creating mode, we have been met with some challenges. Mostly is that when Yahaha started up, we have never thought that we want to add editing features into the runtime. Because if you have tried our platform, you may see that we have dedicated studios for various of editing features. But when you enter the play mode, you just play. But now we want to embed editing abilities into the play mode. So it was not on the plan, and we just find that we want to do it, and we did it. And the second challenge was that we didn't have a lot of time, and it was just around 2 months ago when my leader just uh, talked to me that hey, we want a co-create mode, and that's running in our play mode, and you maybe you can finish it, and we will attend the GDC, and maybe you can have a talk about it. And I was just like, what? So just so you may think that and another thing I want to mention is that we don't have not many developers taking part into this project, only 3 or 4 of them. And so but it turns out that we just finished it, and we currently have a runnable demo that have the features introduced by Poche, and everything runs good. And don't forget, we also have 1 week Chinese New Year in between, so it's quite amazing, I think. So why can we implement this thing such fast? I personally think it's not only for our hard work, but we did do some hard work, but also the architecture that Yahaha's runtime was built on. That is an ECS runtime architecture. So here I want to show the basic architecture that is in the co-creating mode, and the graph here shows the architecture design for co-create. And please first look at the right side, and it actually shows the actual architecture of the current Yahaha's gameplay runtime. That is you can see that the right half side is composed of two parts. Left part is object world, and the right part is the ECS world. And let me say, the object world and ECS world are combining together with some link. You see that one mapping and end-to-end mapping. The object world roughly equals to the unity scene that contains the game object with the mono behaviors, as well as specially designed Yahaha game components. Here just the game components is the special components introduced in the Yahaha's runtime, that we can link the object behavior with the ECS word. And on the other side, the ECS word is made up of pure ECS entities and components with stateless systems handling the logic. Each of the game objects and its entity representation in the ECS world. So the relationship between the game object and the entities are one-to-one mapping. So one game object, then one ECS entity. Each they are one-to-one mapping. And when you see one line down, the game components, each game object can have multiple game components, and every game component represent a specific feature that the game object can provide, like a mover that can move a game object from one place to another, or some behavior, some other behavior like rotator that rotating the object around and around again. And so each each game components are supported by an ECS components that only represent the data set. So the play mode systems will handle those data to make the logic works. And that is basically currently the Yahaha's runtime. And when you look on the left side, that is what we have introduced in the co-creating mode. It's like you can see most of them are the same, except for the components are from playing to editing, and the systems are also, we have edit mode systems that handles the edit logics specifically. So so the two modes switch between each other, just like a mode switch. And other thing we have to do, you see, is that just change the ECS components from editing to playing, and we just change the systems from edit mode system to play mode system. Then we can do the mode change, just like when we have finished the editing, we can test the play. And when we want to go back to editing, we just do the switch back. And the ECS architecture benefits the development in many aspects, includes but not limited to the first one, edit results synchronization persistence. Because in the ECS architecture, everything is represented in data. So if we want to do the synchronization, or we want to persist the edit result, we just manipulate over the data, and that's all right. And the second thing, the second one is the guarantee of performance, because one example for this would be our edit mode systems update logic. When the system updates, change filters are applied against the ECS components, so that only changed components are handled by the systems. That means when you do the edit, only those data that are edited are handled by the system. And we think that editing an object is not very high frequency, so most of the time the system will not run so crazily, so we can guarantee the performance does. And the third aspect, separation of view and logic. This point is not actually a merit itself, but it can bring a lot of advantages. One example would be when a client is editing some object, the object's view system will be switched to a local first mode. That is, we just close the view system for that object, and always follow make the view update always follow the user's input, so that every input user gave to the client will have responsive and smooth response. Like if you drag an object on your screen, then the object follows your finger very smoothly. Not like if you use wheel system update, then the object will only listen to the server update, so that will be a little bit laggy. Oh, then the fourth aspect, the ECS architecture provides control of fine granularity control over the entities. Here I have 3 examples, but the first one is that when we are in the editing mode, we don't want most of the entity running, right? Because the logic should be locked, and we just want to edit them. So we can add simply add an data to those entities, so that each system should exclude this data. So any entity with that data should not run its logic, and in that way we control those entities not running their logics. And the second example could be, oh, sorry, what's going on? That's fine. The second example could be we can add some specific component to some specific entities when we want. If we want to drag an object on the screen, we don't want the object to respond to not respond so smoothly. So we can add an Yahaha transforms no sync component data. So the transform view system will look at that data and know that we don't want the appearance to sorry. Let me just read this. System level entity control. We also have system level tagging components to achieve various effects. For example, Yahaha transform no sync to stop syncing transform data from ECS transform components to their render engine. This is useful when clients want to directly control the entity's render transform. Another example could be Yahaha editing components, which marks an entity as being edited by someone. Systems can use this tag to find entities for drawing border lines to prevent other co-creators from editing the same entity, and do some busy check about the entity's state, so that every state is updated. And the third example is that word reloading is what we do when we do the mode switching from the edit mode to the play mode, or from play mode to the edit mode. And this feature is very useful for editing and play mode switching. When co-create switches between editing and playing mode, we can simply do the word reloading, which is first release all the entities and components and break down those system instances. So because we do the ECS, when the data and the system are distracted, then everything is distracted. And then we can reconstruct the system instances and make up the data again. So every logic will be bring back from the beginning, and in this way we finish the mode switching, or we finish the word reloading logic. Sorry. So you can see many of the co-created features can be naturally supported by the ECS architecture. However, we did have some areas that the original architecture failed to cover, and we had to extend the original architecture to correspondingly to fulfill the requirement. Here, I'd like to take two cases or three cases we had handled. The first one is how we handle user input. In our architecture, we use client-server architecture for net code. That is, the client will send its command to the server, and server handle the command, then send back the change to the client. So you can see that every tick we just send a command. Command from client to server. Like in this graph, you can see that from in tick 100, the client will send command 100 to server, and the server will receive that command and handle it at tick 100. So however, you can see that the command system is not is not so flexible because it the each frame we have to send one command to the server, and the command type is fixed. Like if we have command for keyboard input, and that command will just be the keyboard input, and maybe it's a long value type that represents each key press state, like 1 for pressing, 0 for not pressing, and so in the editing mode, the user inputs are mostly from the graphic user interface and can be of great variety, including object operations such as you may spawning something, destroying something, or duplicating the object. Also, some transform operation when you want to grab and drag something using your touch screen, or do some axis-wise position editing, or rotation editing, or scale editing. Also, we have game components to edit. So each field of the game components can be edited. So the command can be very difficult to handle because we have so many types of user input. And in addition, more and more user input tabs are on their way coming into co-create editing mode because we are extending the ability of co-creating. Just so 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 we must have a new way to handle the user input, not just the original command system. So to cope with such case, we introduce a command queue to handle the cases. So the command queue have the following features. The first is supporting multiple command types. You can enqueue any command type into the queue, and the queue is just the raw buffer of memory. So if only the command is of struct type, that means there is no reference type in it, then you can enqueue it to the command queue, and it can take record of it and send it when needed. And the second one is sending arbitrary number of commands every frame. Because we are using a queue, so there is no need that you have to prepare one command for each frame. You can the queue can just be enqueued when something happens, because just like when the user try to spawn something, then we enqueue and command like a spawning command. When the user drag an object, then we enqueue and command like a dragging command. And the third one is reliable transmission. This is accomplished by storing the command queue for a short time. Before server have sent a commit or an acknowledge packet back to the client will hold that data. And if the server find that the client lost, there is some command lost, then server will tell command that, oh, I have lost some of the command. Though then the client will resend those command again, so the server can continue that queue. And the fourth feature is that continuous memory allocation. Uh, this is quite straightforward, just because both server and the client are storing the queue in a raw buffer of raw memory buffer. So the memory allocation is continuous, and handling them will be better for performance, because you can take use of CPU cache line or something like that. And so that's the first difficulties and how we handle it. And the second difficulty is that how can we represent the game component added result in ECS? As you can see here, list the three of our supported game components, and each of them grow in different shapes. And we have many of such game components, and in the future, we even want to introduce user customized game components. So in such case, these components can be of different shape, and we want to represent in the ECS world, because we want to take advantage of ECS ability, so that those components editing result can be synchronized automatically. And so so how we solve this problem? Because we find that those components are most of made up of data. So maybe we can have a JSON view of those components, and then when we have a JSON view of those components, we think that maybe it's a tree-like thing, because when you have a data of JSON, you see that it's recursive. It's a recursive data structure. Like you can have a map and a list in the map, and um, and in the list you can even again have a map, like a recursive structure. So when we want to map to that structure, we also have to have an recursive structure or a tree-like structure. And so we introduce the custom property which have such structure. So in the graph, in the right side graph, you can see that we actually have three entities, and the root entity is the map, and there are two sub entities. One is for string, and one is for another map, and you can see it's a tree-like structure, and it maps well to the original JSON data. And in this way, we can represent the component added result, like this graph shows, to the ECS data, like this graph shows. And there's one benefit in doing it this way, because we are separating the component editing result into different entities. So when the components change partially, for example, the co-creator maybe just edit one of the field, then in the ECS world, we only have to handle one of the entity, or one component of one of the entity. That will save a lot of CPU time. And when we do the data synchronization, we can also just focus on the changed entity, the changed component, and it also saves a lot of network bandwidth. And the third difficulty we met with is how can we handle the added result persistence. It would have been straightforward to do persistence for an ECS architectured game. In fact, if you have all the data, then you just store the data into some cloud service or some place otherwise, then you can do the persistence. And when you want to load the state back, you just download the storage and do the deserialization, get the components back, then every state is back, and you run the system. You can run the system uh, just like before the storage, the persistence, and here the graph shows how we handle the scene persistence. You can see that if we have entity A, B, C in the scene, we just store them sequentially, and the components are also stored alongside. And if you see the right side graph, and it's an uh, more detailed graph when it comes to one of the components. I take translation as an example, which store the position of an entity, and you can see there is x, y, z axis positions, and when it do the persistence, it will store its persistent ID and the XYZ value. And that is quite straightforward. But when it comes to compatibility solution, it's a little bit hard to handle, because when we do the persistence like that way, we just store the raw data, and that will provide us a lot of performance gain. But when we want to do the load the data back to the state, then there will be some problem when if the data structure have changed. For example, here shows an translations change. If that is just an example, because there should no for the force axis W. This is, for example, if we had an YA translation that have XYZ position, and we do the persistence, and for some reason we change the YA translations definition to position XYZW, then it would be hard to read that state back, because we when we do the storage, we only have the XYZ position. So how should we know that there is a structure change, and how should we tackle with it? The first proposal is that we add a version number for compatibility check, and that is only for check. With the version number, we can know that there is some data structure change. Then we know we how to handle it, but we still don't know how to handle it. And the second point gives an proposal of how can we handle it. That is, we also store the ECS components schema meta for safely deserializing all the data. That is, when we do the persistence, we not only store the data like XYZ, we also store how the data was like. Like we store we we store the YA translations structure. So in the storage, we will know that there is an struct that is named YA translation, and it must have 3 axis position. And and then when we do the deserialization, we know we can compare the two schema, and now we know that for YA translation there is one more axis position W. So in this case, we can just handle the W, because we didn't have W data, so we can just use a default value for W, and that is very common sense for a lot of serialization systems. When we don't have the data, we just make it a default value. and but sometimes when we want more sophisticated logic for default data handling, and we can use the third proposal, and we can provide some uh, a particular data update handler for some data for updating data from older version to a newer version, and most of the time we don't want to use this because it will make the code hard, more and more complex, hard to read, hard to maintain. So that is how we handle this case. And here shows some future technique works that we want to introduce into the co-creating mode. And first is integrating with the AOI system for large word editing. Yahaha runtime provides AOI system itself, so maybe we can also integrate with it so that we can support more people editing bigger word. And the second is the pre-presentation in object spawning. That is for better user experience. When you want to spawn an object, currently we must wait for the server's response. But the more smooth way should be that when you drag that thing into this scene, then that object just appear immediately, and that is the pre-presentation or prediction in presentation in representation. And the third one is the more editing target, just like scripts, environment, terrain, voxel, and etc. And the first one is previewing in editing result on the fly. That is just when we just want to preview some specific game object. We In this case we can have some ability to just run the logic for that object, but not for all the object. We don't have to reload all the scene. And the fifth one is that allow sharing edits and tool and merging edits from other players. That is just some social stuff. You can share your edits to the scene, and others can take your share and merge these edits to their own edits, so that it can build a more complex world. And that was all for the technique part. And here is the shout out that we are going to have exciting and enjoyable events in our booth. So please don't lose the chance to come and explore more about Yahaha's platform. And you may want to scan the QR code there, and we can uh, and we can have more communication on the WhatsApp. And so, oh, that's all. Yeah, thank you.